So this will be a short video to talk a little bit about the layout process, which is what you're going to be doing next on the base part that you've already milled. And so here's a few things that you'll need to reference. Specifically for this video, you're going to need to get out page 15 in the lab section, which is the drawing of the base, because the base is going to give you a lot of information about what to do. And then John will separately talk to you about the layout process as part of the lecture, and there are some notes for that on page 25 in the handout section. So first off, if everybody could open up to your drawing of your base, then we'll be using that over the next few minutes to describe what it is you're going to be doing. And while you're getting that out, one more thing. The chapter in the textbook, section E, is what discusses the layout process itself. And we're mostly going to be dealing with precision layout, which allows you to identify locations within plus or minus thousandths of an inch. Okay, before we proceed with showing some operations with the layout process, there was a question about the surface plate. So this is your granite surface plate, and just want to mention briefly the proper way to place objects on the surface plate and the proper way to remove them. So here's, for example, let's say a height gauge. You're going to use a height gauge on the surface plate. The proper way to do it is you rest the height gauge on the side and you rock it up and then slide it on like that. And the same thing is when you're removing it, you'll slide it off like this. Now what's the purpose for doing that? This is a granite surface plate, so granite is brittle and it can chip. So we don't want to be causing any mars or any damage or nicks or chips by just placing something right straight down on the surface plate. Another object that you may use is an angle plate. A couple of your groups have used this already. So an angle plate, again, you would rock it up and slide it off, and then when you remove it, you would remove it like that. Also, this goes for parts as well. So here's one of the base plates. So if you're going to put the base plate on, then again you would rock it up and over and then slide it on like that and remove it the same way. Let's now talk about the drawing of your part. So the reason we're doing the layout process is because before you drill these two holes in the base plate, you have to identify their location accurately on the part. So the drawing tells you all the dimensions that are important here. And you'll also notice that these dimensions are all referenced to this lower left-hand corner. All the dimensions come off the left side from the bottom and from the left side. So there's something on this drawing that you probably won't normally find on a drawing. If you look in the lower left corner, there's an X. So what does that X mean? Well, that X is like a reference mark for you, so that when you're doing the layout, you're making sure that you're locating the holes correctly from this lower left corner, which again is the reference corner for all the dimensions on the drawing. So what you're actually going to do is you're actually going to punch some kind of a mark in that lower left-hand corner, a permanent mark, so that you properly do the layout. So to do that, you have some punches here. We have a set of lettered punches. We have the whole alphabet and a hammer. So you're going to actually just, and of course this is soft aluminum, so these steel punches will easily put a mark in there. So you pick whatever letter you want and go ahead and punch it in the corner. And this is something we need for the lab, but you can certainly, if John has time, you can do it during this class. Okay. We have several hammers and also those punches. Okay. All right, and no injuries, please. All right, so the next thing that's going to happen is once you're all set with your reference mark, then we can apply what's called layout fluid. So let me show that to you here. Okay, so the layout fluid comes in these blue containers. This is a company called Dychem, and they make other colors other than blue, but we usually get blue. And if you look at this demo engine on the bottom, you can see the blue layout fluid was painted on the bottom, and in the general area where those two holes were drilled. And the purpose for the blue layout fluid is to highlight the scribe marks, because you're going to use a scriber to scribe the location, exact location of the hole. And the blue layout fluid just allows the scribe marks to be highlighted and easily visible. Otherwise, you could still see them, but it would be not as visible on just the plain aluminum. So this is something that you want to do outside. You just take your part and the layout fluid outside, paint the fluid in the general area where the holes are going to be, and of course you know from your drawing, you can look at the drawing. And then you just have to wait 3 or 4 minutes outside for it to dry. Otherwise, if you do it inside, it has a smell that we probably don't want inside. And again, if you have time during this class, it's a nice day outside, then everybody can bring their part and the layout fluid outside and apply the layout fluid. That'll just be an extra step that we don't have to do in lab. You'll be all ready there. Okay. Now getting back to your reference mark that you're going to be punching, how do you know what corner on your part? Well, all you have to do is compare your part to the drawing. So you can see that there's one dimension here, which is the 4.00, which we measured for information. It's measuring across the two sides that you did not machine. And then the 4.00 is the dimension that you did machine, and that's across these two sides. So you just have to orient your part to match the drawing. In this part, the punch mark would be in the lower left corner. Now, if you would prefer to have it here, you're punching on the side that's going to be down on the table, and it's not going to be visible when your engine is running. So you just pick whatever side you want. You could punch here, you could punch there, or the two corners on the other side. Now let's talk a little bit about the height gauge and the scribing of the locations. So once you have the layout fluid applied, then you're going to do all of the scribing over here at the surface plate. And you want to have your drawing with you. And you'll also notice here's a base part, and then I also have the angle plate. The only purpose of the angle plate here is as you're scribing the part, it's just a way to steady the part, because otherwise it's very unsteady and you may not get an accurate result. So it's just a way to stabilize and hold up the part while you're scribing. Okay. Now the height gauge, I don't know if we've talked about it much in lab. So the height gauge is actually very similar to the calipers. If you compare the two, the scale on the beam and on the dial are exactly the same. The height gauge has a range of 8 inches. This particular caliper is 6. There are 8-inch calipers as well. Okay, so the reading, it shouldn't be a problem. Now in terms of zeroing it, when you first use a height gauge, you want to bring it all the way down so it touches the surface plate, and just check that the reading is 0. If it's not, you can adjust the 0 the same way you would adjust calipers. Now, the reason we're using the height gauge for the scribing is if you look at the measuring surface of the height gauge, there's a very sharp pointed scribing edge right here. It's actually a little carbide tip on the height gauge. So we're going to use that sharp edge to scribe locations across the part. For this step, don't do this step here in your regular class. We're going to do all the actual scribing of locations during the lab, and we'll do it together. Okay. There's another feature of the height gauge which allows you to set the dimensions exactly. So if you look at your drawing, let's say we're going to start with your reference mark that you punched down here in the lower left corner, and your layout fluid would be applied right here. So if you look at the drawing, inspection point number 5 says 1.250. So we're going to set the height gauge at exactly 1.250 and then scribe across. And then the next one you might do is the 2.750, set the height gauge and then scribe across. Then you're going to rotate the part and then scribe the other dimension, the 2.000. So here's how you would set the height gauge. So what you're going to do is you can just manually bring the height gauge to 1.250 or close to it. You won't get it exact. Let's say I bring it right about there. Okay, then there is a set screw right here that you would tighten, and then there's a thumb wheel right here which would allow you to do your fine tuning. You can actually fine tune it so that it's exactly 1.250. Oops. Right there, and once you get it exact, then you tighten. There's another second set screw down here which locks it in. So you've locked the instrument exactly 1.250, and then you go ahead and scribe. And then you make sure, before you try to move it, then you unlock it so that it moves freely, so you're not forcing the instrument. And then you go on to your next dimension, in this case the 2.750. Now you also don't have to scribe all the way from one side of the part to the other. You only have to scribe in the general area where the hole is going to be. If you did scribe all the way across, it won't matter. Remember, this is the side of the base that's going to be sitting down flat on the table when your engine's put together, so nobody's going to actually see what's down there. All right, so again, leave the scribing for the lab, and then this week we'll be doing the drilling of those locations. Now, what happens after you scribe? Well, there are several more steps after you do the scribing, and I'll talk about those in a minute. All right, so the last step before you actually do the drilling is you're going to use several punches to punch your scribe locations, and the textbook talks about these. So you have a layout punch which has a very sharp point, and I think that's more like a 30-degree point, and then that's going to be the one you're going to punch first. So you're going to, as accurately as you can, locate that point at the intersection of your two scribe marks, and then you'll use the hammer to punch a mark. And if you have to use a magnifying glass to get it exactly right, sometimes you actually can feel the intersection of the scribe marks with the punch. And then you follow that up with a center punch. Center punch has about a 60-degree angle, and then you'll punch the same location right over your first punch. That just kind of enlarges the hole and prepares for drilling. So the punch marks make it easier to line up your drill when you go to actually drill that location, and it helps to prevent your drill from wandering a little bit. So that's the punching. So those are all the steps we'll do before we get to drilling.